Welcome to my pre-algebra class. We're on chapter 10, section 2, and we're going to be working with circles. The definition of a circle is a set of all the points equal distance from a given point. So here's your given point, and all the points on the circle are the same distance from that center. The center, so we could label the center and call it A. The radius is a line segment from the center of the circle to a point on the circle. So if I take this point here and this point here and connect them, well, let's see if I can deselect them because it's not working right now. Hang on a second. Okay, that makes that segment from the center to the outside, that's a radius. So FG is a radius. And a chord is a line segment whose endpoints are on the circle. So I could choose the circle. I have to deselect everything. Choose the circle. Put a point on the circle. Choose the circle again. Put a point on the circle. And if I take that point, I'm going to move that point a little bit. See if I can move it. Let's move it over here. All right, take that point and this point and construct a segment. This is a chord. It's a line segment whose endpoints are on the circle. A diameter is a special chord. It goes through the center. So if I take and construct a point, let's choose a circle, construct a point on the circle, and then choose a point on the circle that's exactly across from it. Looks pretty close. And then connect them. Okay, I think I have to deselect again. Take this point and this point, construct a segment. It's almost there. If I move this over here, then that chord is a diameter. And the diameter is always twice the radius. So from here to here is a radius, and from here to here is a radius. So those are the basic definitions of the parts of a circle. Another thing that you need to know for this section is pi. Pi is a ratio of the distance around the circle, the circumference, to its diameter, the distance across the circle. And the value of pi we're going to use is either going to be 3.14 or 22/7 depending on how our problem is set up. So those are the only values I want you to use. Do not use the pi key on the calculator. Pi is determined when you take the circumference of any circle and divide it by the diameter, you always get pi. So watch what happens here on these problems. So if I deselect everything, if I take the circumference, measure the circumference, and then measure the diameter, and then I go to calculate, and I take the circumference and divide it by the diameter, you get 3.14. Now watch it with this one. So deselect everything, take the circumference, measure it. Take the diameter, measure it. Now calculate the pi for this one, which is to take the circumference and divide it by the diameter, and again we get 3.14. And one more time, measure the circumference for this circle, measure its diameter, and then calculate the circumference divided by the diameter, and again we get 3.14. So that's pi. And then the last thing is, how do we find circumference without a system such as this? Circumference, there are two definitions we're going to use, or two formulas. Circumference is pi times the diameter. Remember, pi was found by taking the circumference divided by the diameter, so we just solve it for circumference. So we take pi times the diameter. So if we take, I'm going to do that right now, this is the diameter, and we know pi is 3.14, so I'm going to take circumference, diameter we have, so we're going to calculate, we're going to take pi, 3.14, multiply it by the diameter, which is this, and we get our circumference, which is 18.8. Now it might be a little bit off if I go ahead and measure it. I get 18.7 because they're using a more precise measurement for pi. And here's another type of problem. If they give us the radius, we're going to have to double it in order to get the diameter. So we're going to use the formula 2 pi r. So I have the radius figured out here, so let's figure out the circumference. So it's 2 times the radius times 3.14. And we come up with a circumference of 63. Now if I take the circle, oops, can't get to the circle, and measure its circumference, it should be close to that. In fact, it is the same. So those are the two formulas we're going to use, and as I do the problems with you, I'll show you why we use 3.14 for one and 22/7 for the other. So your notebook paper is out and headed. You skip a line, it's 442, guided practice 1 to 13, exercises 1 to 18. So on 442, number 2, what characteristic of a circle is represented by the number pi? Well, the characteristic is the ratio of the circumference divided by or to the diameter. Circumference over diameter. Number 4, identify 2 frequently used formulas for circumference. Well, we just finished that. Well, if we were given the diameter, then the formula is pi times d. Or if we're given the radius, it's 2 pi r, because we have to double the radius to get the diameter. Number 6, the directions are exercises 5 and 6 show a series of steps that apply one of the circumference formulas to the given figure. And each step replace the blank with the number that makes the statement true. Well, we're just going to work it out. So number 6, we're going to use the formula 2 pi r. And they give us the circumference on the circle is 43.96 equals 2, well, they use the approximation symbol since we're using an approximation of pi, times something r. Well, in this case, we're going to use 3.14 because this number here is not divisible by 22 because we would have to divide. So our reason we use 22/7 is if we have a number over here that's divisible by 22 or on this side by 7. So we get 43.96 is approximately, multiply 2 times 3.14 and we get 6.28 R. And then we solve for R by dividing both sides by 6.28. And then on our calculator, if we take 643.96 and divide it by 6.28, we get 7. So our radius is 7, approximately. And problem number 8, use the figure at the right. And so I'm going to go ahead and draw that figure and put the things that they have in it, the chords and the radii and so on. So this is V, W, this is the center, this is U, T, X, and ZY. And they give us this measurement as 29 inches. That's the measurement for the diameter. So problem number 8, identify as many radii, chords, and diameters as are shown. Well, let's start with the radii. It's plural for a radius. So that would be any line segment from the center to the circle. So we have, I'll just start with OV, line segment OV, line segment OX, line segment OT here, and line segment OU. Chords would be any line segments whose endpoints are on the circle. So I see one right here, VW. And the diameter, TX, and ZX is a chord. All the line segments with endpoints on the circle. And diameters is a special chord that goes through the center, and that would have to be line segment TX. Problem number 10, find the radius. Well, they gave us 29 is the diameter. So take 29 and divide it by 2, and that would give us 14.5 inches is our radius. And problem number 12, find the circumference of a circle with the given measurement. So we're going to have to find the circumference, and they gave us the radius, so we're going to use 2 pi r. So the circumference equals 2 times pi, and I look at the radius is 8, and 8's not divisible by 7, so I'm going to use 3.14 times 8. So using my calculator, so it's 2 times 3.14 times 8, and we get 50.24. And checking the book, they're rounding to the nearest tenth on most of these problems, so we'll round to the nearest tenth. It's 50.2. Okay, the exercises, number 2. We have a circle again. And it's set up the following way. Labeled P, OR, this is Q, and this is S, and they give us this length right here, 8.6 right here. So identify as many radii, chords, and diameters as possible. So radii from the center to the outside of the circle would be line segment OP, line segment OR, line segment OS, and line segment OQ. This was Q here. Chords, line segments whose endpoints are on the circle would be PR, QS, SR, and QR. And the diameter, there are two of them. PQ is a chord, PR is a chord that goes through the center, and QS is a chord that goes through the center. Problem number 4, find the diameter. The diameter is 2 times the radius, and they gave us the radius, so 2 times 8.6 equals 17.2. Number 6, find the circumference of a circle with the given measurement. They gave us the diameter, so we're going to use the formula C equals pi times D. And 10.5 is divisible by 7. So we're going to use 22/7 for this one. So it's 22/7 times 10.5. And 7 goes in there 1.5 times. So 22 times 1.5 equals 33. So our diameter is 33 centimeters. Problem number 8. They give us the radius is 2.5, so we're going to use the formula for that involves radius, 2 pi r. So we're going to use 2. The radius is 2.5, that's not divisible by 7, so we're going to use 3.14 times the radius 2.5. So our calculator, 2 times 3.14 times 2.5 gives us 15.7 as our circumference. Problem number 10, I use the diameter, so circumference equals pi times diameter. 3.5 is divisible by 7, so we're going to use 22/7 times 3.5. 7 goes in there 0.5, and 22 times 0.5 gives me 11. So our distance around the circle is 11 meters. Problem number 12, the radius is 14 inches, so we're going to use the formula 2 pi r. 14 is divisible by 7, so we're going to use 22/7 for pi. And we can cancel the 7 with the 14, making 2. So 2 times 22 is 44, times 2 is 88 inches is our distance around the circle, the circumference. In 13 through 16, find the radius and the diameter. So there are 2 parts to these problems, so find the diameter and the radius. So number 14, we have a circumference of 33. So we can find the diameter first. So 33 is the circumference. And on these problems, if I use 22/7, since I'm given the circumference of all these, I'm going to have to use the inverse of this, or the reciprocal rather. It'll be 7/22 multiplying both sides by that. So I need to check to see if the circumference is divisible by 22 in these problems. And that'll tell me use the 22/7. 33 is not divisible by 22, so I'm going to use 3.14D. Divide both sides by 3.14. So 33 divided by 3.14 gives me 10.5. So I'll use 10 point, rounding it to the nearest tenth, I'll be 10.5 equals the diameter, and taking 10.5 and dividing it by 2 gives me 5.25 for the radius. Remember, round to the nearest tenth. When you have a decimal that keeps going forever. So that's going to be rounded to the nearest tenth. The book actually gives the answer as 5.5 So you could leave that there, or I would accept 5.3 also. Number 16. We have the circumference is 34.54. And we're going to find the diameter first. And I check to see if 34.54 is divisible by 22. And it is, it's 1.57. So I'm going to use 22/7. So 34.54 equals 22/7 times D. So I'm multiplying by 7 22s. So D equals 22 went in there, 1.57. And times that by 7. And I get 10.99. Which rounds to 11. So the diameter is 11. Divide that by 2. And we get 5.5 equals the radius. And problem number 18. The radius of a front wheel of a tricycle. So here we have a tricycle. And the radius is 6 inches. Excuse me, the front one. The radius of the front is 14, and then we have the back one, and its radius is 6. And they want to know how much larger is the circumference of the front wheel than the circumference of the back. So the circumference of the front wheel is 2 pi r, and it's divisible by 7. So we're using 2 times 22/7 times 14. 7 goes into 14 twice, so this comes out 88 for the circumference. This one, 2 pi r, and since 6 is not divisible by 7, we'll use 3.14. for pi, and using our calculator, 2 times 3.14 times 6 gives us 37.68. And then they ask how much larger is the front tire than the circumference of the front tire than that of the back. So take 88 minus 37.68, and we get 50.32. And that's our answer. That concludes the evens. Check the back of the book for the answers to the odds as you do them.